Hi everyone, today we're going to be showing you our scheduler in a presentation. So the presentation has been divided into six main sections. The first will be introduction, where we basically introduce the problem and how it needs to be solved. The requirements would basically show you the requirements for a solution for the problem. Um, we're going to show you how the scheduler works, as well as the main components of the scheduler that make it work, as well as the results and trade-offs, which is basically the findings from our experiments, as well as the conclusions, where we summarize our findings and our implementations. Now, for the introduction, we have an arcade game in a shopping center, and it's just one machine that many customers can use. Each customer is limited to a certain amount of time that he can use the machine for. The use of the game would be facilitated by the robot manager, which in our case would be a scheduler. And the arcade game is similar to the CPU. The customers would be similar to processors.
The requirement that our algorithm should fulfill is total wait time for high priority customer should be lower than that of low priority customer. It should also have smaller total wait time as compared to the baseline algorithm. It should have smaller longest response time as compared to the baseline algorithm, and it should also have few switches between customer as compared to the baseline algorithm.
So in this section, I will just describe how the scheduler works on a high level. So at every iteration, it will check for new arrivals and place them in their respective queues. And then it will check if there's a customer on the machine that has used the time they're allowed to. And if there is, that it will remove them and place them in the back of their respective queues. And after every 20 time units, it will reorder the queues in order to reduce starvation. And at the last bits of the iteration, it will check if there's no customer in the machine. And if there is no customer, it will use the shortest remaining time first algorithm to schedule a new customer onto the machine. So now I will describe the main components of our algorithm. I will first start with the shortest remaining time first algorithm. So in this algorithm, the aim is to basically schedule a customer onto the machine with the lowest time remaining. So this first for loop, we iterate through each customer in the queue, and for each of them, we check the remaining time. And if we find one that has the lowest remaining time, we store their index so that we can push them onto the front of the high priority queue later. And now the next step, we have to make sure that the customer that at the front of the high priority queue currently is not there because they've been starving. And if that condition is false, then we can continue the algorithm. Now, the next component is the reduce starvation algorithm. Now, the aim of this function is to reduce the starvation of a customer. And the way we do that is by iterating through the queue, the low priority queue, and ensuring that there is no customer that has been waiting in the queue for longer than 15 time units. And so this is what this double for loop does. If we find a customer that has been waiting for longer than 15 time units, then we'll push them to the front of the high priority queue. And we just need to repopulate the queue here because we cleared it earlier up there. And now the last component of our algorithm is a demote customer function. And so this function is basically demote a customer after they've played in order to allow other customers to use the machine as well. And so what happens is it has a for loop and we iterate through all the customers, and if we find a customer that has played before, basically we check to see if a customer has been playing. And if we find one that has played, we have to push them to the low priority queue. And this is just repopulating the queue because we cleared it earlier up here. And now we will discuss the trade-offs.
In the baseline scheduler, we had 8 seconds before you remove the customer and place in the back of the queue. But in our implementation, they're removed in the short period of time. This helps reduce the total wait time. And we can see the graph now. As you can see, we have compared the performance of both the algorithms and visualized it using graph. We can see that our implementation of the scheduler is satisfying all the requirements mentioned before, but it does come at a cost of a longer wait time for low priority customers. So to conclude, we introduced the problem that we are trying to solve using our scheduler. Then we specified what are the requirements that our scheduler should fulfill. Then we described on a high level how our scheduler should work. Then we explained the main component of the scheduler using our code. At the end, we discussed the result that our scheduler produced and the trade-off we had to deal with. Thank you. Have a nice day.